I listened to what I read like 3 times, but then I thought, what in the world are you talking about? So I will read more. Einstein's Times. For its enduring echoes, Einstein's 1905 article on special relativity on the electrodynamics of moving bodies became the best known physics paper of the 20th century, and its dismantling of absolute time is its crowning feature. Einstein's argument, as usually understood, departs so radically from the older, practical world of classical mechanics that the paper has become a model of revolutionary thought, seen as fundamentally detached from a material, intuitive relation to the world. Part philosophy and part physics, Einstein's rethinking of simultaneity. I just checked the dictionary and it just upsets me. This word has come to stand for the irresolvable break between modern physics and all earlier framings of time and space. Einstein began his relativity paper with the claim that there was an asymmetry in the then current interpretation of electrodynamics as a symmetry not present in the phenomena of nature. Almost all physicists around 1905 accepted the idea that light waves, like water waves or sound waves, must be waves in something. In the case of light waves, or the oscillating electric and magnetic fields that constituted light, the something was all pervasive ether. Most late 19th century physicists considered the ether to be one of the great ideas of their era, and they hoped that once properly understood, intuited, and mathematized, the ether would lead science to a unified picture of phenomena from heat and light to magnetism and electricity. Yet it was the ether that gave rise to the asymmetry that Einstein rejected. Number two. 어딨어? 없네. Okay. In physicists' usual interpretation, Einstein wrote, a moving magnet approaching a coil at rest in the ether produces a current indistinguishable from the current generated, and when a moving coil approaches a magnet rest in the ether. But the ether itself could not be observed, so in Einstein's view, there was but a single observable phenomenon, coil and magnet approach, producing a current in the coil, as evidenced by the lightning of a lamp. But in its then current interpretation, electrodynamics, the theory that included Maxwell's equations describing the behavior of electronic and magnetic fields, and a force law that predicted how a charged particle would move in these fields, gave two different explanations of what was happening. Everything depended on whether the coil or the magnet was in motion with respect to the ether. If the coil moved and the magnet remained still in the ether, Maxwell's equations indicated that the electricity in the coil experienced a force as the electricity traversed the magnetic field. That force drove the electricity around the coil, lighting the lamp. If the magnet moved and coil stayed still, the explanation changed. As the magnet approached the coil, the magnetic field near the coil grew stronger. This changing magnetic field, according to Maxwell's equations, produced an electric field that drove the electricity around the stationary coil and lit the lamp. So the standard account gave two explanations depending on whether one viewed the scene from the point of view of the magnet or the point of view of the coil. I feel like I'm becoming Sheldon. As Einstein reframed the problem, there was one single phenomenon. Coil and magnet approached each other, lighting the lamp. As far as he was concerned, one observable phenomenon demanded one explanation. Einstein's goal was to produce that single account, one that did not refer to the ether at all, but instead depicted the two frames of reference, one moving with the coil and one with the magnet, as offering no more than two perspectives on the same phenomenon. At stake, according to Einstein, was a founding principle of physics: relativity. This is why people watch YouTube.